Hi student friends, this is Ramaiah, faculty of AS Engineering Academy. Welcome to AS Engineering Academy. Today's session, Computer Organization, RRB JE, Computer Science branch. In this, first of all, we are going to discuss the syllabus pinned by the board, RRB board, nothing but first number system, logic gates, first number system, logic gates, Boolean algebra, flip-flops, instruction set, DMA. It is the syllabus pinned by the means provided by the RRB JE. Truly speaking, it is the combination of both digital and computer organization subject, but given title was only computer organization. In this, first four topics, these are belonging to, digital subject, next two topics are belonging to CO subject, computer organization, but given title was only computer organization. After watching most of the previous papers, RRB JE previous papers, I came to one conclusion. That conclusion is like this. Here, only this information is not sufficient for solving the previous RRB JE questions. Because of that reason, I have converted this syllabus into our style syllabus. Okay. It is our style syllabus. First one, number system. It is very important. It is very important topic. Definitely we expect minimum one question from this for each and every RRB exam. Next, Boolean algebra and logic gates, sequential circuits, these are nothing but flip-flops, registers and counters. Next, digital computer basics means CPU basics. Next, memory. Next, cache memory mapping techniques. Next, direct memory access. Next, instruction set of a basic processor, magnetic memory, 8085 microprocessor. Truly speaking, we had some questions on 8085 microprocessor. It is important topic, but according to the given syllabus, it was not included here, but you should remember this one, 8085 microprocessor. This one plays very important role for securing more number of marks. Now in this, first four topics are belonging to digital, remaining topics are belonging to CO. I have converted the given syllabus into our style after watching most of the previous RRB JE questions. At the same time, already our faculty members discussed the weightage of each and every subject along with this subject also. Look here. In this, weightage, in previous sessions, already our faculty members discussed the same. Here, especially our CO subject weightage. CO means, you should remember, it is the combination of both digital and CO. Minimum 10% and maximum 15% in the given total number of questions. Out of 100 questions, minimum 10%, maximum 15% means it is the importance of the subject. It is the importance. Next. Next, look here. Already I told number system. It plays very essential role, because if you watch any paper, minimum one question will be there at the same time. Frequently, some questions are there on DMA topic. Before going to discuss the previous questions, let me explain one more point. First of all, you remember on which topic, on which areas, topics means here on which areas more number of times questions were asked. Next, in this, especially the topics tapped more number of times. First one, especially number system. It is the order of priority. Number system. Second one, logic gates. Third one, memory. Fourth one, DMA. Next, fifth one, 8085 microprocessor. These topics are more number of times tapped. Next, remaining topics are tapped less number of times. Remaining topics are tapped less number of times. That's why keep more focus on these topics while preparing the RRB JEE. Now we are going to discuss some questions, previous questions. Not only solution, you should understand how to solve the question at shortest time. Execution time is very essential in any competitive exam. Now look here. First question. This question was given in RRB JEE 2014 green shift. Earlier, already our colleagues discussed all those things, provided most important and valuable information regarding the same, including weightage of each and every subject. Now, our subject is computer organization. Previous questions. First one, what is the decimal equivalent of the hexadecimal number? It is the hexadecimal number, given hexadecimal number. He asked for the decimal value. In this, given value is nothing but AB60 with the base 16. For converting the same into decimal system base is 10. Here, A, B, 6, 0, given base 16 means multiply the data, given data with given base. Starting exponent is 0 and goes on incrementing. Finally, add all these partial results. A means 10 into 16 power 3. 16 power 3 is nothing but 4096, because 16 power 3 can be written as 2 power 4 whole power 3 means 2 power 12. 2 power 12 is nothing but 4096 plus B means 11. 16 square means 256 into 11 plus 16696 plus 0. Now, after adding all these, the result will be like this. Here, 40960 plus 256 into 11 plus 96. We got answer 43,872. Okay, na? It is the correct answer, 43,872. Already I told the importance of the number system. Okay, na? It is more frequently tapped area. More frequently tapped means that area is tapped more number of times. Next. Our answer is 43,872. Come to next question. Watch question carefully. A flip-flop can store. Options are like this: 1 bit of data, 2 bits of data, 3 bits of data, any number of bits of data. One flip-flop. One flip-flop is used to store only 1 bit along with its complement. Means whatever the name of the flip-flop doesn't matter. Whatever the name of the flip-flop doesn't matter. That flip-flop can be SR flip-flop, JK flip-flop, D flip-flop, or T flip-flop. Flip-flop is having two stable states, Q and Q bar. If Q is 0, automatically Q bar 1, and vice versa. Let it is SR flip-flop or JK flip-flop or D flip-flop or T flip-flop, but it is used to store only 1 bit. Why only 1 bit? Because only Q is considered as, generally, Q is considered as output, Q is considered as main output, and Q bar is considered as complementary output. That's why it is used to store only 1 bit of data. Whatever the name of the flip-flop doesn't matter. It can be SR flip-flop, JK flip-flop, D flip-flop, or T flip-flop. Okay? So correct option is A. Next. The correct matching of the following pairs is. Here, he asked the matchings. Left side, DMA IO, cache, interrupt IO, conditional code register. Right side, high speed RAM, disk, printer, ALU. In this, first of all, DMA. Full name is direct memory access. Full name is direct memory access. IO means input or output. So in this, DMA IO is used for making data transfer between secondary memory and primary memory. Primary memory is also known as main memory. In this DMA IO, it is applicable for disk. It is used to transfer the data between secondary memory is also known as disk memory, like hard disk, floppy, CD, compact disk. Now in this, A belongs to, A perfect matches to, next, cache memory. It is nothing but high speed memory, 1. In the given digital computer, cache memory is the fastest memory and high speed memory it is. Next, interrupt IO and conditional code register. Conditional code register is also known as flag register. Flag register is connected to the output of ALU. Look here. Let it is ALU of any processor. Let it is ALU of any processor. This output is connected to flag register. Flag register is also known as conditional code register because flag register is used to store different conditions. Those conditions are carry flag, zero flag, parity flag, sign flag, etc. That's why conditional code register is applicable for ALU. So it is 4th. Next, interrupt IO. It is used to connect printer, means 3. Means, what about perfect? Answer for this, A2, B1, C3, D4. Correct option is B. Okay, na? This question was given in 2014, Redshift. Next. Look here. Which of the following are typical characteristics of a RISC processor? RISC machine means RISC processor. Which of the following are typical characteristics of a RISC machine means RISC processor? Generally, processors are divided in two ways. All processors are divided in two ways, RISC and CISC. RISC processor permits minimum number of instructions, means instruction set size is minimum, addressing modes also minimum, and minimum number of clock cycles is sufficient to execute an instruction, and it is designed with more number of processing registers. Because of that reason, most of the arithmetical and logical operations are performed in between processing registers. Memory visit is not required frequently. Processor visits memory for only loading and storing application. For most of the arithmetical operations, only internal registers means processing registers are used. At the same time, partial results also stored in the processing registers because RISC processor is designed with more number of processing registers. That's why he asked the characteristics of RISC processor. By keeping these points in our mind, look here, instruction takes multiple cycles. No, it is false because RISC processor can execute the instruction at shortest time, means minimum number of clock cycles. Cycle means clock cycles. Next, highly pipeline. Yes, because of pipelining, it performs, means RISC processor is going to execute the operation at shortest time. Next, multiple register sets. Yes, it is designed with 75 to 100 number of registers. Yes, both B and C. So for this, correct option is both B and C. Okay, na? This question was given in 2014 Redshift. Next. Question is like this. Output of an exclusive NOR gate is 1. Output of an exclusive NOR gate is 1. Which input combination is correct? Means, to get this one, to get 1 at the output of XNOR gate, XNOR gate is also known as coincidence gate. What does it mean? Output of XNOR gate is 1 when inputs are coincident, means when both inputs are same. Here, number of inputs is not mentioned, means we consider only 2 input gate. When number of inputs is not mentioned, we consider only 2 input gate. Let inputs are A, B. Y is output. Then truth table will be like this. Look here. For 0, 0 and 1, 1, what XNOR gate gives? XNOR gate gives 1 because both inputs are same. For 0, 1 and 1, 0, XNOR gate gives 0 because output of XOR gate is complemented. Then result is nothing but XNOR gate. Now, let it is XOR gate. Its output is getting complement. Output of XOR gate is 1. Look here, output of XOR gate is 1 when both inputs are different. Means output of XNOR gate is 1 when both inputs are same. That's why, what about correct answer here? Here, A1, B0 means both are different, means it gives 0, but he requires one output. That's why it is false. 0, 1 false. 0, 0, yes, because both are same. It becomes correct answer when correct A, B and C are wrong only. So correct answer is C. Okay, no? Next. It is important question. Watch question carefully. Convert the following SOP expression into an equivalent POS expression. Convert the following SOP expression. SOP means sum of products into equivalent POS, product of sum expression. Now it is the given expression. ABC plus AB bar C bar plus AB bar C plus AB C bar plus A bar B bar C. SOP expression is nothing but the combination of minterms. First you find the minterms for this ABC. When input is 1, 1, 1, then only we can write ABC. While writing SOP expression, we find only high output. We write the terms for only high output. After finding high output, for that combinational input, if input bit is 0, we write A bar. Input bit is 1, we write A. That's why we write ABC means all inputs are 1. Here 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1 means what about minterms here? 1, 1, 1 means 7 decimal value. Nothing but 4, nothing but 5, nothing but 6, nothing but 1 means these are nothing but sigma m means sum of minterms. What those are? 1, 4, 5, 6, 7. With three variables, maximum number of combinations to be generated is 8. Means 8 terms are going to produce. In these 8 terms, these 5 are minterms, means remaining 3 are max terms. These combinations are used to provide high output, means remaining combinations are used to provide low output. That's why these are minterms, means remaining all are max terms. What about remaining terms? Maximum number of terms to be produced is 8. Number of minterms is 5. What about remaining 3? Those are nothing but 0, 2 and 3. These are max terms. 0 means 0, 0, 0. Okay. 2 means 0, 1, 0. 3 means 0, 1, 1. Now we are going to write the POS expression, not SOP. POS means product of sums. In this, we write the term for 0 outputs. When input bit is 0, we directly write the literal. When input bit is 1, we write its complement. So what about this? A plus B plus C, Y. Y plus product of sum terms. Product of sum terms. Next. A plus B bar plus C into A plus B bar plus C bar 0, 1, 1. So find the correct answer here. Correct answer is B. Watch it. A plus B plus C, A plus B bar plus C, A plus B bar plus C bar. Okay, na? Next. Look here. Which of the following is the most widely used alphanumerical code for a computer input and output? While operating a system, we use keyboard. In that keyboard, so many symbols are there. Here, 0 to 9 numerals are there. Higher case alphabets are there. Lower case alphabets are there. Special symbols are there. Space is there. So that keyboard is designed with which type of code he asked. It is nothing but ASCII. What is full name? ASCII, ASCII. American Standard Code for Information Interchange, ASCII code. So correct option B. Our keyboard provides 128 symbols, means all different numerals, plus, minus, dot, all these symbols, 128. Next. Look here. This question is related to 8085 microprocessor, but already I told earlier, in syllabus, 8085 microprocessor was not mentioned, but sometimes questions were there. This area is frequently tapped, not more number of times, minimum number of times. The circuits in the 8085 that provides the arithmetical and logical functions are called. Not only in 8085 processor, not only in 8085 processor, in any processor, any microprocessor, ALU is there, control unit is there, some number of registers are there. What he asked in the question, the circuits in the 8085 that provides the arithmetical and logical functions. ALU is used to perform arithmetical and logical operations because its full name is arithmetical and logical unit. ALU performs the arithmetical and logical operations under the guidelines of control unit, means ALU works under the control of control unit. So correct answer B. This question was given in 2014 yellow shift. Next. Which of the following is not a basic element within a microprocessor? He asked the element which is not in a basic, the element which is not available in the microprocessor. Arithmetical and logical unit, ALU, compulsory ALU will be there. In any processor, compulsory ALU will be there and control unit also will be there. Along with these two functional units, some registers are there. Example, A, B, C, D, E, H, L, F in 8085 processor. These are the temporary registers. These are used to hold the operands during program execution. Now look here. Which are not available in the microprocessor? He asked the question like that. Microcontroller, ALU, temporary register, accumulator. In ALU, accumulator is also there. That's why here ALU is there, temporary register is there, accumulator is there, but microcontroller will not be available in microprocessor because of that reason. For this question, correct answer is A, because microcontroller is not fabricated in the microprocessor. 2014 yellow shift question. Okay, na? Next. Look here. First watch the question. Try to understand the question. First understand the question carefully, then only go for solution. Output of an AND gate with 3 inputs, A, B and C is high. When? He asked the characteristics of AND gate. AND gate can be designed with 2 input or 3 input or 4 input or 5 input. Generally, AND gate, NAND gate, OR gate, NOR gates can be designed with 2 or more inputs. He asked the property of AND gate, and it is also 3 input AND gate. Here, he requires high output here. To get high output here, what about the possible input combinations? Output of AND gate is high when all inputs are high only. Whatever the number of inputs doesn't matter. Whether the gate is having 2 input, 3 input, 4 input, 5 input doesn't matter. Output of AND gate is high when all inputs are high only Means here, when all these are high, then only output will be forced to high. So what about correct option? C. In AND gate, if any one of the input is 0, output will be forced to 0. It is the characteristic of AND gate. This question also given in 2014 yellow shift. Next. Look here. Very important question. First, try to understand the meaning of the question. If a signal passing through a gate is inhibited by sending low into one of the inputs and output is high, the gate is. First, try to understand the question. If a signal passing through a gate is inhibited by sending a low into one of the inputs and the output is high, means whatever the name of the gate doesn't matter. First look here. Understand the concept clearly. He wants to, let it is the logic gate. He wants to get high output here. In which type of condition? Whatever the number of inputs doesn't matter. He didn't mention the same. If any one of the input is 0, he wants to get the high output here. In AND gate, if any one of the input is 0, output will be forced to 0. But when AND gate output is complemented, the resultant gate is nothing but NAND gate. Means in NAND gate, if any one of the input is 0, output will be forced to high. It is nothing but NAND gate. For clarification, look here. If you consider 2-input NAND gate, that inputs are A, B, output is Y. Look here. For 0, 0, 0, 1, 1, 0, output is 1. When both inputs are 1, then only output will be low. In this, he asked the high output. When minimum one input is low, that's why it is nothing but NAND gate only. Correct answer B. First, try to understand the question. Then only go for solution. Okay? Next. Convert the following binary number to decimal. Here it is the binary number he gave. 0, 1, 0, 1, 1 base 2. He asked the decimal value. In this, already we discussed this type of question. Given base is 2, so 2 power 0, 2 power 1, 2 square, 2 cube. 1 into 2 cube means 8. Anything into 0, 0. Here 2 plus 1, nothing but 11. Not in binary, in decimal. What he asked in this? Convert the binary to decimal. So correct answer A. I think half minute time is more than enough for this one. If you have any doubt in the answer, self-check is there. Here, convert 11 decimal to binary. Our answer must be 0, 1, 0, 1, 1. Means in this, look here. Given value is 11. Divide this one with target system base. Means 2 5s 10, remainder 1. 2 2s 4, remainder 1. 2 1s 2, remainder 0. Collect the remainders in LIFO technique. LIFO means last in, first out. So for this 1 0 1 1 with base 2. Same. Here he gave 5 bit. Keep 0 here. No problem because it is unsigned data. When type of data is not given in default, we consider that as unsigned data only. Next. DMA is particularly suited for data transfer between the dash. For this, look here. DMA, direct memory access. Just only 2 minutes, look here, because it is very, very, very important concept. Look here, it is processor. It is known as cache memory, and it is known as main memory. In general language, main memory is known as RAM, but truly speaking, cache memory is also RAM. But in general language, main memory is considered as RAM. Most of the non-technical people use RAM for main memory, but cache memory is also RAM. Now, it is nothing but DMA controller. DMA controller is placed between secondary memories. These are nothing but secondary memories. Sometimes secondary memories is also known as disk memory and IO device. Now, DMA controller is placed between secondary memory and main memory. Sometimes main memory is also known as RAM. Here, I am going to explain some basics also. These are nothing but data buses. Here, cross line is there, means it is not single line, multiple lines. While executing a program, first processor tries to get the instruction from cache memory. If it is available, operation is hit, otherwise miss. When hit is occurred in cache memory, no other memories are involved in the operation. When miss has occurred in cache memory, then reference goes to main memory, means processor visits main memory. Then what happens? If it finds the word, the associative block means group of words, is transferred from main memory to cache memory. Later, processor directly speaks to cache memory. When main memory also fails to supply the target instruction, then operating system takes responsibility to initiate DMA controller. Why? To transfer the target file from secondary memory to main memory, because secondary memories are operated with electromechanical devices like head and motor. Because of that reason, processor is not interested to speak to those memories directly. When processor is directly communicated with these memories, efficiency of the processor will be degraded, means system performance will be degraded. Because of that reason, DMA controller is placed between secondary memory and main memory. When miss has occurred, what miss has occurred in cache and main memory, with the help of operating system, DMA controller will send a signal to processor. Name of that signal is bus request. After receiving bus request is used to ask the bus services for making data transfer. For making data transfer, buses are required. Those buses are nothing but address bus, data bus, control bus. Generally, these buses are under the control of processor, but DMA controller requires those bus services for making data transfer between secondary memory and main memory. After receiving this request signal, processor completes the current operation and handovers all the buses to the DMA controller by sending bus grant signal. GT means grant signal. After receiving bus grant signal, DMA controller becomes master. Processor loses the control on buses, means during DMA means direct memory access. Processor neither reads nor writes, because during DMA all the buses are under the control of DMA controller. Look here. During DMA, the processor, also known as CPU, neither reads nor writes. Why? because all buses are under the control of DMA controller. So DMA controller is placed between secondary memories and main memory. Sometimes main memory is also known as RAM. Now, better to watch the question now. DMA is particularly suited for data transfer between the disk drive and CPU. CPU does not involve in DMA operation. Disk drive and RAM, yes. Disk drive is also known as secondary memory. Secondary memory is also known as disk memory. Hard disk, example is hard disk. So, DMA control is placed between disk memory and main memory. So, correct answer is B. Okay, next. Look here. Which of the following is also referred as universal gate? Universal gates means any target expression can be implemented with these gates. Means only such type of gates are sufficient. Whatever the number of gates required doesn't matter. Whatever the number of gates required doesn't matter. Only such type of gates, means only one type of gates, is sufficient to implement any target function. Then it is known as universal gate. Examples are nothing but NAND gate and NOR gates. Here, which of the following is also referred as universal gate? NOR gate, here only NOR gate is there. NAND gate is not given. If NAND gate is also given, both are nothing but universal gates. Here it is not possible to implement all the gates with the help of AND, all the gates with the help of OR, and all the gates with the help of NOT. Any gate can be implemented with NOR gates. Only NOR gates are sufficient to implement any gate. Like that, if only NAND gates are also sufficient to implement any gate. So correct answer, NOR. Next. It is excellent question on sequential circuits. Determine the output frequency of a frequency division circuit that contains 12 flip-flops with an input clock frequency of 20.48 megahertz. Watch the question carefully. Understand the question. Now look here. Determine the output frequency of a frequency division circuit. Contains 12 flip-flops with an input clock frequency of 20.48 megahertz. Here, asynchronous counter is especially used for frequency division. Asynchronous counter is especially used for frequency division. In this, how many flip-flops are used? 12 flip-flops. Look here. It is very, very, very important question. Watch this one. Here 12 flip-flops are there. Name of the flip-flops are not given, not needed to discuss. Flip-flop 1, flip-flop 2, flip-flop 3. Like that. Flip-flop 12. In this, what happens? Main clock is applied for first flip-flop. It is nothing but clock frequency. Now this output is connected as the clock input for this. This output is connected as clock input for this. Same. Last but one flip-flop output is connected as the clock input for this. Okay now. One flip-flop can provide two distinct states, bit 0 and bit 1. One output is nothing but one state. Here how many flip-flops are there? 12. One flip-flop is used to generate 2 distinct states. N flip-flops are used to generate 2 power n distinct states. Now, total number of flip-flops is 12, means total number of, means maximum number of states to be produced is nothing but 2 power 12, means 4096, approximately 4K. What is the input clock he gave? Input clock he gave 20.48 megahertz. In this input clock here, 20.48 megahertz. What he asked in the question? In question, what he asked? Output frequency. First, you know the relation between input and output frequency. F out. What is the meaning of F out? Output frequency means frequency signal available here is last flip-flop output frequency is nothing but final output frequency, nothing but F in by total number of states it counts. Here total number of states to be counted is 4K. Here F in is nothing but 20.48. What it is? Megahertz. Here it is nothing but 4K means 4.96 kilohertz. So approximately it is nothing but it is not 4.96, it is 4.096. So approximately it is nothing but 5. Okay. So what about output frequency here? 5. Here it is megahertz, it is kilohertz. Automatically mega means 10 power 6, kilo means 10 power 3. That's why it is nothing but kilohertz. So what about our answer? 5 kilohertz. You remember one point clearly. F out is nothing but F in by total number of states it counts. One flip-flop is used to count only 2 states. 2 flip-flops are used to count 4 states. N flip-flops are used to count 2 power n states. So here F out is nothing but F in 20.48. Simple explanation. By total number of states it is going to count is 2 power 12, means approximately 4K, it is 20K. So answer is 5. It is mega. It is mega. Mega means 10 power 6. Okay, na? Next. Watch this question. Excellent question it is. This question belongs to memory. Now, which of the following statements about static RAM, SRAM means static RAM, is not correct? Which of the following statements about static RAM, SRAM, is not correct? First one, SRAM uses flip-flops. Yes. DRAM means dynamic RAM. Design requires, means if you want to store 1 bit in dynamic RAM, it requires only 1 transistor and 1 capacitor. Generally, FET is also referred as a transistor. FET means field effect transistor. Capacitor services are required while designing dynamic RAM, but no capacitor is required for designing static RAM. Here SRAM means static RAM uses flip-flops. Yes. Static RAM is faster than dynamic RAM. Yes. Next, SRAM uses capacitors. So no. Next, SRAM is costlier than DRAM. Yes, because in our system, cache memory is designed with SRAM. Main memory is designed with DRAM. Main memory means what we are speaking 4 GB, 8 GB, 16 GB. It is designed with the DRAM, main memory, and cache memory is designed with SRAM. Cache memory is the costliest memory, but it is fastest memory. No capacitor is required for storing a bit in the cache memory, means SRAM. That's why what he asked, Not correct means false statement. Here it is false. SRAM uses capacitor. It is false. Okay. Next. This question was given in 2015. September shift. Now, magnetic tape is A. All memories are divided in 3 groups. What is first one? Semiconductor memories, also known as electronic memories. Second one, magnetic memories. Third one, optical memories. Magnetic memories are nothing but magnetic hard disk, floppy, magnetic tape. Magnetic hard disk and floppy. These 2 memories are operated in random access. Random access means for accessing a word, whether it is reading or writing operation, for any word, time is universal, means same amount of time is sufficient for accessing any word. It is the meaning of random access. If it is sequential access, then what happens? Accessing time is different from word to word. Magnetic tape memory permits only sequential access, means one after another. If we consider magnetic tape means tape recorder cassette, let the cassette is having 6 or 7 songs. Here first song will be played first, last song will be played last, means if you want to access the last song immediately, not possible through tape recorder cassette, but it is possible to access any song at the target time interval in magnetic hard disk or magnetic floppy. That's why magnetic tape is a sequential access memory, means word access time is not same for all. Okay, next. What about next one? Which of the following is known as universal logic gate? Already we discussed similar type of questions. 2014 question. It is 2015 question. Already I told earlier, you should know on which type of topics they have tapped more number of times. Nothing but universal gates, number system. Now in this, universal gates and logic gates also. Already we know NAND and NOR gates are the examples for universal gate. Here, NOR gate is not there, only NAND gate. So correct answer C. Next, one more question on logic gates. Output of XOR gate is 1 when? Here, if we consider XOR gate, what about the property? Let it is 2 input gate. Look here. For 0, 0, 1, 1, XOR gate provides 0. For 0, 1, 1, 0, XOR gate provides 1. Output of XOR gate is 1 when both inputs are different. Both inputs are different, yes, because he asked the one output. Both inputs are 0, what it provides 0. Both inputs are 1, what it provides 0. Both inputs are same, what it provides 0. That's why correct answer is option A. Look here, considering the x and y as Boolean variables, means binary variables, the simplest form of the Boolean expression x plus xy is, here x plus xy, in this x is common, 1 plus y, 1 plus something is nothing but 1, it is nothing but 1 into x is nothing but x, answer is, okay na? Now, thank you very much for providing this chance. At the same time, I recommend or suggest our beloved students better to watch our videos, watch our deep learning videos and follow those concepts and questions clearly. If you practice well, practice makes man perfect, not only man for all, practice makes us perfect. If you practice well, there are more number of chances to get the job in the same. Okay, na? Next, better to subscribe the same and try to reach your goal. Thank you very much.